We're going to stick to working with functions in this section and more specifically writing and interpreting functions. So applying them to real world events. So first and foremost, let's just start with some basics. If I have this ordered pair x, y, that can also be written as x, f of x. And in this ordered pair, x is expressed as the independent variable, and f of x is defined as the dependent variable. So we're pretty much saying these two statements, that the y, or the f of x, depends on x. And just like independent sounds, that's exactly what it means. That x value, that can stand alone, but the f of x depends on that x value. Let's do a couple of different examples. So let's look at this example. Austin is buying bagels for a family gathering, and each bagel cost $1.50. So we're going to answer the following regarding the relationship between the total cost and the number of bagels purchased. So now the question you should ask yourself is, which depends on the other? Does the total cost depend on the number of bagels purchased, or does the number of bagels purchased depend on the total cost? So let's think about that. The more bagels I purchase affects my total cost. So when we think about it, the bagels are my independent value. My dependent is the cost. So we would say in this case that x represents the number of bagels, and our dependent is the total cost, because we would phrase this as the total cost depends on the number of bagels purchased. So the next part of this question is going to ask us to come up with a function that represents the relationship between these two things. So n of x, so that represents the total cost of our bagels. And we know the cost of each bagel. It's $1.50. So we would express that function as 150 times x, because x represents the number of bagels and n of x represents my total cost. So 150 times the number of bagels will give me my total cost. So then they ask us to evaluate n of 12. Well, we're going to plug 12 in for x, and we get 18. What does that tell us? It tells us that when we've purchased 12 bagels, the total cost is $18. Let's look at this second example. So we have Kylie joining the Frequent Coffee Club Buyer program at a local shop. The program cost $15 per month, which allows her to get discounted coffee prices of $2 per cup. So what are we comparing here? Well, we're going to compare the number of cups of coffee purchased to the total monthly cost. Again, folks, you're asking yourself, which is the independent variable and which depends on the other? Okay, so we have the question of the independent variable, and that would be the number of cups of coffee, because that stands by itself. It is independent. But what does depend on the number of cups of coffee? The monthly cost. And it's because we would say that the monthly cost depends on the number of cups of coffee. So here is the one thing that is a little bit different in this problem. we have this fixed cost of 15. So it doesn't matter if we purchase any cups of coffee, every month we pay that flat price of $15. So that's going to factor into our function b of x. So we would say for b of x, that b of x equals 15 plus 2 times x, keeping in mind that x represents the number of cups of coffee that we purchase. So to evaluate b of 6, we would plug 6 in and get 27. And that interpretation tells us that when 6 cups of coffee have been purchased, the total cost that we pay is $27. So here's an example of how this looks in Delta Math. So here we can see Anna was offered a job after college earning a salary of $45,000. This is like the fixed price in the coffee problem. She'll get a raise of $5,000 after each year working for that company. So let's see if we can compare the relationship between salary and number of years working. So you're asking yourself, does the salary depend on the number of years that Anna works, or does the number of years that Anna works depend on the salary? Well, let's look at the options. The independent variable represents now here's something that's helpful. Time is almost always the independent because nothing really affects time. We would say that our salary here depends on the number of years Anna's been working. So the independent variable is number of years, and our dependent variable is the salary. And the reason is because our salary depends on the number of years Anna works. So that function, though, we have to take into account that Anna has $45,000 regardless. So $45,000 is going to be the starting salary plus, then we take into account the number of years and the bonus, 5,000 x. So then that would represent our salary, R of x. So R of 7 means we're going to plug in 7 to x, and we would $80,000, meaning 7 years after being hired, her salary will be $80,000 per year.